Hello everyone, this is our capstone presentation. For our capstone, we were working with Mozilla AI on their Blueprints project. Before we get started, I would like to introduce our team. So my name is Kenya.
My name is Maitreyi.
My name is David.
And I'm Connor.
So for our project, we worked on Mozilla AI's blueprints. So currently, AI has a high knowledge barrier to entry due to needing to understand the different libraries and technologies behind them. Meanwhile, proprietary AI is easy to use, but it can be costly due to API calls, having to pay for those. They can pose security risks because it's hosted on a different server, and it can be difficult to customize because you kind of have to use whatever their models are fine-tuned to do. So blueprints are an open source initiative that was started by Mozilla AI that are local AI workflows that leverage open source models designed to accomplish a specific AI task. So they're designed to be easy to use and that they're very plug and play with all the tools needed to get started with them and comprehensive documentation. They're customizable to fit different use cases, and they're easy for the documentation makes it so that they're easy to change up. They have low hardware requirements, as a lot of local AI has you need a very powerful GPU, but the blueprints are designed to work on low-end GPUs or CPU. And they offer an applicable use case right out of the box so that you can just run them and then get something working right away.
So for our project, we split up into two teams to be able to build two blueprints. Me and Kenya worked on sketch to wireframe, while David and Connor worked on optical character recognition blueprint. Sketch to wireframe blueprint aims to be able to help developers, young developers, to generate UI wireframes by putting in their hand-drawn sketches or prompt to be give which would give out a code and the preview for the wireframe. It is also editable, so if the user likes the wireframe that is generated by the sketch to wireframe blueprint, they can edit it in draw.io.
Right. And we created an OCR to LLM document parsing pipeline. The goal is to allow users to batch process images locally. They are also customizable. So our initial design was built for bank statements, but this could be adapted to medical records or any form of document that you would like to parse locally and keep it secure.
So for the LLM document parser, our original plan was just to make an OCR or optical character recognition blueprint, because these often require APIs and can be hard to customize. And if they're run locally, they often have higher hardware requirements or can be difficult to use. So our plan was to make an OCR workflow that was easy to use with a low hardware requirement that you could use to just pass in like an image and read the contents of it, put it in some text form. To do this, we wanted to have a PyPy package that would allow people to integrate it into their Python projects easily, a GitHub repo with an easy-to-use CLI tool, a Google Colab notebook, which also has the advantage of providing a GPU for you, in case you didn't have one and wanted to use a higher end model, and a Gradio web UI so that it was easy to use with the GUI. However, the main issue with this is that this plan is that there were already some kind of good solutions out there for this use case. So for example, Tesseract OCR has been around for a while and it's very lightweight and it has its own CLI tool. Easy OCR is another one, same thing, it's been out for a while and it also has its own CLI tool, a little bit less lightweight, but still quite lightweight. And then while we were working on this plan, a new model came out, Ulm OCR, that does have its own web UI as well, but it also had a pretty easy to use Python app or open source Python workflow, but it did have a higher hardware requirement. However, we kind of figured that there's, because of these different tooling options, there was kind of this niche was kind of already filled, so we wanted to do something different. So our new plan was to add in an LLM to process after the OCR was done. And this could allow us to go directly from a document, such as in our demo use case, we use a bank statement, and then produce some structured output in like JSON format, CSV, an Excel file. And so for our demo use case, this is you put in a bank statement and it prints out a CSV with all of the transaction information. Some advantages that this has over using a traditional LLM is that it runs locally, which means it's more secure, so you can use more private information with no issues, such as bank statements or tax documents, things like that. And then it's also customizable since it's not a multimodal model that does two different types of info. It's just two different models. You can completely swap out the different models as you like with your to fit your use case or to fit your hardware requirements. And then because we changed our project, we also changed the deliverables. We decided not to create a PyPy package because it kind of became less modular with all of the tooling that we added. And so we didn't want to incorporate that all into one package. And then the Google Colab notebook was less necessary because since it was so customizable with you can use lower end or higher end models, then we didn't really need that integrated GPU anymore. And here's a demo of it working.
All right, so here we've got our config file with some options to change the models for our Gradio web app. So OCR is set to OCR Mac. Our LLM is set to Ollama 3.2. You can also change the LLM prompt or the export type, as well as your input or output address. So here we are just putting in one image, though we do have the option to process a folder full of images as well. So OCR Mac is going to process this. The LLM is going to give some structured output and then give us a CSV file to use how we please here. All right, looks like it ran. We've got our CSV up top. Good. And then we learned a few things along the way here, considering that we weren't too familiar with OCR models or had much experience with LLMs prior. So we learned how to interface with AI libraries like Docling or Ollama to allow the user to have multiple options as far as models are concerned for processing power or hardware requirements. We learned how to develop with Gradio to create our web application to demo and run the pipeline. We also learned how to function with an open source workflow and how to collaborate using open source documentation and interface with the MK docs workflow as well in order to create doc strings and auto generate some of our readmes and getting started in accordance with the Mozilla AI blueprint template.
So now moving on to the sketch to wireframe blueprint. So for our original plan, our initial blueprint was intended to function like a generator, so a starting point to help spark ideas or to begin from scratch. So our original features were going to be text to wireframe, so like given a prompt, Q&A form, and sketch to wireframe. But some of these had a couple issues. So for starting off with text to wireframe, this feature is already available with many LLMs accessible online, and the Q&A form wireframe feature had very limited use cases and it lacked flexibility. So we decided to stick with the sketch to wireframe idea and just make it more innovative. And when we began this process, one of the biggest challenges that we faced is just our limited experience with the tools that we needed for this project. So being able to adjust to the different tools used that being able to adjust to the tools that were being used and getting our hands on with actually working with models slowed our development a little bit. So we took a while to get started, but once we got started, and then we can go to the next slide, we were able to get going with our new final approach. So like I mentioned, we decided to go with the sketch to wireframe blueprint, and so this blueprint we wanted to make it as a tool that brings existing sketches to life digitally. So the idea is that the user will upload an image of their sketch and they will also add a prompt describing the image. And our blueprint will return a generated XML code that can be downloaded and previewed. And then with the preview feature, if you don't like it, you can edit it with the draw.io editor, and we can see the demo on the next slide.
So this is our demo. You can see that we've uploaded a sketch and a prompt to help with the sketch. And upon generate wireframe, it gives out a code. And if you click preview link to the preview, it will take you to the preview, and clicking the pencil button will take you to draw.io, where you can edit the wireframe elements and place them how you like and want your wireframe to look. As you can see here, we are placing the elements to fit our sketch wireframe that we had uploaded. We can save this draw.io wireframe to our computers, and there you have your wireframe. Some of the things that we can move to the next slide. Some of the things that we learned from building this project is we got hands-on experience with building with Gradio, which is a responsive and user-friendly interface that interacts with AI models. We were also able to understand how fine-tuning a model testing, and model training works to be able to fit our project more. And we also learn how to reassess and adapt to the project scope as challenges come forward. We were able to gain experience with individual work as well as working in teams and work collaboratively as teams. And thank you to our mentors. That's all we have.